You are all welcome to second AI Expo Tokyo Big Site Japan. Let's spend some time to understand what is going on in Silicon Valley with the terms of artificial intelligence and how Silicon Valley is revolutionizing artificial intelligence with technology and several other ways. Macnica.ai, your partner in global AI revolution. My name is Johan, and I'm currently head of AI platforms and businesses at Macnica Networks. Before that, I had positions in H2O.ai, Big Data Perspective, Microsoft, and ISR. If I try to introduce myself with my career in IT, I would say I started my career with a company called ISR. Headquarter was in Tokyo, Japan, but I was working mostly from Silicon Valley, Foster City, California. My role was software engineer, and I worked there about 4 years from 2001 to 2005. After that, I went to Seattle working at Microsoft. I spent about 8 years over there working with Fortune 500 customers and various telecom companies in Asia. I did started as in Windows 18, but I was very early engineer in Windows Azure, and I was the key contributor to build HD Insight project over there at Microsoft. I left Microsoft 2013, joined a company called Platfora in Silicon Valley, where I worked with the various financial and government sector to deploy Platfora big data appliance to do the super large scale intelligence. After that, I had my own company called Big Data Perspective, which I founded. I took money from investors and I ran that company about 2.5 years, and where I had opportunity to work with very large scale big data software providers such as Cloudera, Huttonworks, Mapper, and various others. I built an appliance which was designed to understand the workload happening on a big, large data clusters and identify any problems using anomaly detection, use with deep learning autoencoders, and then heal them as well. That company was acquired by Ninja RMM. Then I joined one of the leading machine learning organization in H2O in Silicon Valley named H2O, where I was heading their products and customers. During that time, I had opportunity to work with really very large organization in various industry. And finally, currently, I am at macnica.ai, leading their AI platforms and businesses, especially for Japanese customers first. Working about 17 or 18 years in various IT industries gave me experience within the variety of industries such as retail, healthcare, marketing, finance, insurance, telecom, IT software, and IoT recently with IoT and IoT. It gives me opportunity to really talk about various things happening in various industry and how artificial intelligence is really going to solve problems within those industry as well. Let's understand what H2O.ai open source machine learning platform is. If you are new to H2O open source machine learning platform, it is very popular, one of the leading open source machine learning engine involved. It's used by over almost 220 plus Fortune 500 global organizations. It is used by top 8 banks involved, as well as the top insurance companies and healthcare organizations as well. From community perspective, it is very popular open source machine learning platform. At the time, it's almost used by 150,000 users as of today, and about 15,000 organizations worldwide is using H2O open source platform for their machine learning requirement. So if you are new to H2O, I would strongly suggest you to please take a look at H2O, download it, use it, and if you think there is anything you needed to assistant with, please contact Macnica, and we'll be very happy to assist you using H2O as well. So what we are really going to talk about now? Let's take a look at AI as a solution versus AI as the technology. When we talk about AI as the technology, is basically the engine, and when we talk about AI as the solution, here the term is given as a full-built car. The good thing with technology is that it's really a certain it is something which you really needed to get going. Means a technology required time, engineering, and resource to really make it work, and then you can really take advantage of it. Versus when we talk about solution, it's pretty much ready to deploy. You just get a solution and you start using it. And when we talk about AI, artificial intelligence, at Macnica, we are really looking into AI as a solution. What our value proposition to Asian market, especially starting in Japan, is that we are going to provide AI as a solution to our customers and partners by bringing one of the best available AI solutions globally and providing them to our customers in Japan. What else is happening in AI? One of the key things in key advances in machine learning is a rapid prototyping, where you have data you can feed to an engine and you will get one of the best accurate model it can provide, and this model is really ready to put in production. So that's we call it rapid prototyping. For some of them it could be considered as a black box. For some, it's really good to have a black box because they really do not want to understand the integrate complex methods and technology inside machine learning. They just want to use machine learning as a tool. For them, just loading the data and after processing, getting the results are enough. While others, this black box may not be useful. They really want to understand. So for those who really think that they really need to know more about what is happening in rapid prototyping, they can basically look into inside, which is what is happening. And if we look into deep inside, we can see that basically the rapid prototyping is a data transformation, which is mostly is a feature engineering, building multiple features, multiple useful features from the given data, and then building various states of models, and understanding that how those models are really getting accurate higher and higher, and just keep you will keep that and keep building them until they really find the best model. Once the model is ready, MLI, which stands for machine learning interpretability, is really used to explain the model. And H2O software such as driverless AI is one example of rapid prototyping, where without even knowing anything about complex, intricate learnings about machine learning, you just really can use this software to import your data, load into driverless AI, and just get the best available model as a base model for you to start with. We can if we talk about the MLI. MLI is basically making the AI ready for businesses. So for the regulated industry, if you would like to use artificial intelligence, MLI is something which is going to make it really possible, where the regulators can really understand the explanation provided by MLI regarding the model which really produce the results. There are various ways MLI can be implemented, such as decision trees, partial dependency plots, variable importance, and the lime k-lime methods. Basically, these methods explain the results produced by machine learning models when user scores them, and these explanations are business ready, means business people can very easily understand them and make sense that why the model results are such as what is really given for you. And MLI is a growing field. Several researchers are actually working. H2O driverless AI uses MLI to explain the results, make machine learning ready for businesses. So now let's spend some time about the machine learning life cycle and then how it is really being improved in Silicon Valley. So for last 20, 30 years, even more, machine learning is really popular in insurance industry for over 40, 50 years. So basically the machine learning life cycle consists of three steps: data ingest. Once data is ingested, model is really being built, and once model is built and a final model which is ready, which can be put in production. That model is really put in production, so you start generating results, and companies start taking advantage of those results. While new data is coming, then new model is built and check for accuracy. If accuracy is higher, then higher accuracy model is put in production, and that model is basically generating the results. So that's the 360 view, or the life cycle of machine learning in any organization. Now we will really look into that how the fully automated system of AI can be generated for any business, whether the business is really very small or it's really super large. The process of basically putting together an AI machine learning pipeline is going to be almost same with just a few modifications. So everything starts with data. You really have to collect data from various streams, put together, clean it, make sure it's machine learning ready. And once machine learning ready data is available, you can put this inside in a machine learning system where basically that data is really ingested. Once the data is ingested, we really need to understand to make sure that data is really machine learning ready. Is there any problem or not? If then data visualization and the data validation techniques are really used, which can understand, which can understand and explain if there are any issue with the data. So once a data scientist or a system is really understood that there are no further issue with the data, that data is really ready to go for machine learning engine, and that basically that data is really being fed into a machine learning system, which is fully autonomous system, which basically take the data and start feature engineering using genetic algorithm or maybe some other advanced technology. And in the automated feature engineering process, basically the newer and newer features are generated based on a given data set, and machine learning models are built using some kind of sampling method. During this process, both automated feature engineering and scalable machine learning work side by side. New features are generated, new models are built, models are evaluated, and new features are checked. If features are good, models that helps to build a more accurate model, then those features are kept. Otherwise, those features are dropped. This process runs for several minute to several hours, depending on how this whole scalable automated AI system is really being configured. And once everything is really completed, and this process of automated machine learning and skill is feature automated feature engineering and scalable machine learning, a final model is really generated, which is a most accurate model the system can produce at this given time. This model is basically ready to put into production, and if you would like, you can actually apply the machine learning interpretability to explain the results, which really helps business leaders to understand why the model is results are given as such. And finally, if you would like, you can take this model and you can really extract uh, from the system and deploy it wherever is really needed, in Python, Java, or any other environment, and where this model is really start generating scores for the given data. So that's about a very standard automated AI system, which is really being used for to not only for rapid prototyping, but also to build models at a really very fast scale. And to make this whole thing process, basically is very speedy. The GPUs are really being used at maybe feature engineering scale, or could be in machine learning stage, or could be both. So it's depend on the engine which you are really using for this purpose, and it's all depend on how that is really engine underneath is really designed to support GPU or not. But basically GPUs are really being used with various machine learning engines to expedite this model building process. Now we can really look into how you can really acquire really a higher accuracy with combining various AI machine learning frameworks while doing machine learning. So everything starts from statistical and machine mathematical modeling, and then using automated machine learning, we can make our results even higher and higher. Everything starts from data again. We take this data, we fed into a machine learning engine which has various algorithms, and each algorithm has a various combination of hyperparameters. That data is really injected, and various algorithms with their hyperparameters models are really being built, and all these models are really put together for a validation process, so make sure that a highly accurate model is available, and that highly accurate model is basically provided at the final step of automated machine learning. This model is accurate, highly accurate from the system, and finally this model is really put into the production. So that is something when automated machine learning can be used for one engine, or actually you can use various engines as well when you are using automated machine learning. Now we can look into ensembles which are making which are really providing even more higher accurate machine learning models. And here we could take an example of how ensembles are really adding more accuracy to the given model while taking the advantage of various artificial intelligence and machine learning frameworks. So to understand machine learning ensembles, we again start with data. So we have data which is machine learning ready, and we have various machine learning engines. And in this example, I'm using H2O, TensorFlow, and I'm also using XGBoost, where the various hyperparameters for each algorithms are configured and ready to be used. The data is really being fed into all these engines. It could be parallel, and basically what we are really trying to do is that we are trying to generate the various models, and we are trying to use the validation data, test data, to really score the results. And all those results are really being used to generate even more and more models. So basically you have various hundreds of models are available, and their scores are really being created, and those newer models are really being built top of the scores which are from previous stages. And finally, after several iteration, highest accurate model is really being generated. And this process, in this ensembling process, uh, finally the final model is the highly accurate, which we also call the leader or winner model. This model is really pretty much ready to put into the production. And just to make sure that this whole process can be done in given time, because there are if we use the combination of various machine learning engines or deep learning engines, then various algorithms and hyperparameters, there are really hundreds and thousands of permutation and combinations are available. So the help of GPU, we can expedite this whole process and make sure that everything is really done in really very fast time, so users can take the advantage of ensembles and various algorithms by distributing the workload on GPU and build the final accurate model in really in very short amount of time comparative to everything running on CPUs. So this is how the advancement in GPUs are really being used for deep learning and machine learning. Not every algorithm really supports GPU. However, to make sure that if you can take advantage of GPU, you just need to make sure that particular algorithms does supports GPU. Now we will look into how technology is really advanced in a way where more and more technology is used and less personals are really being used to manage the technology. So previously, various teams were working on either single machine or a cluster to do the machine learning, and basically using the rapid prototyping methods such as automated ML, machine learning, and ensembles. Now you can really put together a really very large server farm which does machine learning, and just use one or two a few person to basically manage this whole process. In this rapid prototyping, you are basically using a very large cluster of machines where you ingest the data, build various run various machine learning pipeline, generate models validate them, make sure they are good for your businesses, and once the models are evaluated, you can put them on production directly. So whole process can be created by very few uh, large machines, but very few personals, and that is really very popular. Whether you are a small organization or very large, you can take advantage of these rapid prototyping methods and really build the machine learning models in very short amount of time. And this whole process basically very fast. You really have very few mistakes because we are really avoiding humans, cost saving as well, and the machine learning models are production ready, which you can put them in production as soon as possible. What else is happening in Silicon Valley? Just to conclude this talk, I would say there are various things are happening at various level in statistical machine learning, neural networks, or deep learning, as well as the GPU hardware. Just to point out few of them, genetic algorithms are really being used to automate feature engineering. Feature engineering is key aspect of machine learning, where you can build out newer features, and you can validate if those features are really contributing to accuracy to the model. If not, then you can drop them. So the bioengineering or the genetic algorithm methods are really being used for that purpose. If we look into neural networks, deep learning, real-time environment at annotations is really being used by various organizations. The inference at the edge is really very popular, and the newer and newer technologies are coming into the existence, where really fast sub-millisecond level inference can be done at the edge, and several objects can be detected within the live frame. Uh, we can also look into that pre-trained deep learning models are available, where you can use them very quickly for object detection, such as a YOLO 3, which stands for you only look once. And you can use these models. They are almost production ready for object detection, or you can actually use these models to add a new learning for your requirement, and then you can use those models for your kind of object detection problem you are really trying to solve with. GPU-based RDBMS, and were really very popular. Several organizations, several startups really put together really very nice projects on that regard. But distributed GPU-assisted SQL queries are really getting popular, where you can even have very fast access to the data. So that's all I really have to share with you. I really appreciate your time. I'm really thankful that you came to our booth and you learn about what Macnica is really doing for Japanese customers, and how we are going to help Japanese enterprises and customers by providing AI solutions. Please do reach out to me at my email avkash@macnica.com, or if you think that we can help, Macnica can help you with your business, with your projects, please contact us, and we will be very happy to help. Once again, I really appreciate your time, and thank you so much.